Good morning. So, good morning. So, less students, I think. Okay. First. So, good morning. Come fast. Okay. So, we will start with the class. Means we will solve some further questions because already it is time is done. Okay. So, we will move to the next question. That is question number 12. How many unit cells are present? How many unit cells are present in a cube? How many unit cells are present in a cube shaped ideal crystal of NaCl of mass 1 gram. Okay. So now the option for this 2.57 into 10 to the power of 21. Option B 5.14 into 10 to the power of 21. Option C 1.28 into 10 to the power of 21. And option D is 1.71 into 10 to the power of 21. Okay? All of you can see the board? So what is that question? How many unit cells are present in a cube shaped ideal crystal of NaCl of mass 1 gram? So which is that option? 2.57 into 10 to the power of 21, 5.14 into 10 to the power of 21, so 1.28 into 10 to the power of 21 and 1.71 into 10 to the power of 21. So these are the options. Can anyone? Whether all of you can see the board? Board is visible, right? So they have told it is NaCl crystal. Okay. So then they have told 1 gram. They have given the mass. So they have given the mass. Okay. Now they have given the molecule. How to find out number of unit cell? Right? How to find out? Okay. So, or anyone, Banu, whether you have solved? I am just asking. Okay, what we have to do here is step 1. Okay, so here means in detail no need to write. To make you understand, I am writing it as step 1 and all. So in step 1, first you have to find how many number of NaCl are present in 1 gram. So that is number of NaCl in 1 gram. That's what we have to do. How to find number of NaCl? How to find the number of NaCl? NaCl can be found by using Avogadro's number, right? See, for example, NaCl is having molar mass as 58.5 gram. NaCl is having molar mass as 58.5 gram. So therefore, now I can tell that for 58.5 gram, we will be having Avogadro's number of NaCl. All of you will agree? That is 6.022 into 10 to the power of 23. So that many number of NaCl will be there in 58.5 gram. So how many will be there in 1 gram? Because they have given 1 gram. All of you are understanding? So first we have to find number of NaCl which will be present in 1 gram. So right? So based on that 58.5 gram of NaCl corresponds to Avogadro's number of NaCl, that is mole concept. And how many will be there in 1 gram? Now naturally, so gram will get cancelled. So answer will be 0.103 into 10 to the power of 23. Okay, so that many number of NaCl is present in 1 gram. Okay, now next step is, that is step 2. Okay, next step is we have to find out, say for example NaCl, it is due to the FCC. NaCl will form the FCC. Yesterday only we have discussed, right? So FCC, how many atoms will be there in a unit cell, right? So now we have information, they have given NaCl. So NaCl forms FCC type of packing. That is FCC type of packing. So that is nothing but in FCC each unit cell will have, each unit cell has how many atoms in FCC? 4 atoms, right? So each unit cell will have the 4 atoms. Each unit cell will have the 4 atoms. Now it's very clear. So for 4 atoms it is 1 unit cell. For 4 atoms it is 1 unit cell. So in that case, how many for? 0.103 into 10 to the power of 23. Right? So for 4 atoms, we have 1 unit cell. In that case, for so many atoms, how much it will be? So atoms will get cancelled. So the answer will be number of unit cells. Anyone got the answer? Okay. So that's where we will get the answer as 0.02575 into 10 to the power of 23, which can be written as 2.57 into 10 to the power of 21. Because we don't have the option for 10 to the power of 23. So we have converted it into 21. So that means option A should be the answer. Option A should be the answer. Whether I am clear? All of you have understood? Okay? So yes, Krishna, yes. Option A should be the answer. how many unit cells are present in a cube shaped ideal crystal of NaCl of mass 1 gram? Cube shaped ideal crystal of NaCl of 1 gram. That is the question. Now they have given a hint telling that the molecule which is involved here is NaCl. Now all of us we know that NaCl is going to form FCC type of packing, where unit cell will be of FCC unit cell, face centered unit cell. Okay, so that's where we have the one information what we have got. Then they have given 1 gram. They have given the mass. So based on that, we can calculate, since NaCl is there, 58.5 gram is the molar mass of NaCl. For so many mass, it is the number of NaCl which will be present. How much will be there in 1 gram? So this is where we have got the answer. Then further, by utilizing the information that in FCC each unit cell will have the 4 atoms, based on that, for 4 atoms 1 unit cell. So how many unit cells will be there for so many atoms? And we got the answer as option A, that is 2.57 into 10 to the power of 21. Okay, so all of you have understood, right? So we will move to the question number 30. Okay, we will move to the question number 30. Now next question is related to amorphous solid. Okay, so next question is related to amorphous solid, but there is one slight variation. In that only there is slight variation. We will find out that one. So now the question here is, glass is a, question number 30. Glass is a, option A, microcrystalline solid. Microcrystalline solid. Then option B, supercooled liquids. Supercooled liquids. Then option C, a gel. And option D, polymeric mixture. Polymeric mixture. Okay. So now, can anyone? Okay. Many of you have written. Okay, Krishna, first you had written. Okay, this is for answer for this question. Okay. So he has written option B, Krishna. Okay. Now, Bhanu Kumar. Okay, option B. Now that's why I told there is slight change. It is actually option A, microcrystalline solid. That is because if you observe it carefully, when you talk about the glass, normally while taking the class I will take the example of windows of related to bus and all, old bus and all, I used to take the example, where at the bottom there will be increasing in the width. Now if you observe it carefully, there are many glass items which will not be applicable like this. For example, a lamp or bulb, they will be exposed to high temperature, right? But whether it will happen same way? No. So we have different qualities of glass. Everywhere it is not applicable. So what I mean to tell here is, wax or candle and all, they can be taken as example for supercooled liquid, no doubt. But when it comes to glass, since it is not applicable for all the things, we can consider microcrystalline solid as the appropriate answer. Because glass have, some of the glass have the sharp melting point also, same as that of the crystalline solids. But it's not applicable for all the type of glass. Therefore, more specific answer can be microcrystalline solid, because it is having crystal structure in small region, unlike any other amorphous solid. Glass is an amorphous solid, no doubt. But in that, it is having a slight proper structure compared to other amorphous solids. So therefore, we can consider this one as a microcrystalline solid. You have to remember this. Okay? So who has written supercooled liquid? If microcrystalline solid option is not there, They have given supercooled liquid and any other option, but no microcrystalline solid. Then you can go with supercooled liquid, no doubt. Then you can go with the supercooled liquid. But when microcrystalline solid is also there as one of the option, then you have to go for microcrystalline solid. All of you have understood? Okay. So shall we move to the next one? So that is question number 14. Next is question number 14. What type of crystal defect? What type of crystal defect is indicated in the diagram below. In the diagram below. Okay. So now diagram in the sense I have to write the NaCl, Cl minus, Na plus, Cl minus, Na plus, Cl minus, then Cl minus, Na plus, okay, Cl minus, Na plus, then once again gap is there, then here Na plus, Cl minus, once again gap is there, Cl minus, Na plus, Cl minus, Na plus, Cl minus, Na plus, second box, and can anyone? This is the diagram. So Na plus, Cl minus, Na plus, Cl minus, like that it is there. Wherever box is shown, it is empty. Where it is not shown, no need to worry. Where it has shown as box, then it indicates that there is an empty space. Now, can anyone? Okay, Banu is telling it is a Schottky defect. What do you mean by Schottky defect? It is nothing but vacancy where there will be removal of ions. Okay, we will see. Now, how many empty spaces are there? 1, 2, 3, 4. 4 empty spaces are there. Right? So, in that case, how many ions have moved? 1, Na plus it is there. That means 1 Na plus is moved from some other place. So that's where we have the Na plus. Then Cl minus, that means it has moved from some other place. Right? So that's where I can see that 2 empty space where Na plus has moved here and Cl minus. So Cl minus has moved here. Okay? But still there are 2 empty spaces which is left over. Still there are 2 empty spaces which is left over. So in that case, what should be the answer? So the answer should be, as Banu has written, it should be a Schottky defect. It should be a Schottky defect. Please remember, in your exam, if they give diagram like this, first observe how many boxes they have given, whether respective ions have moved, we have to find out. Wherever we have similar ions neighbor to each other, that means one ion, it has moved from some other place, interstitial defect, right? Same way, here we can see 2 positions, there is a repeated same ions. That means they have moved from some other place. In all the other region, we cannot find that pattern. Everywhere it is plus, minus, plus, minus, plus, minus, plus. Here one minus is missing, right? So, but here minus, minus, plus, plus. That means one of these 2 ions have moved from some other place, right? So, Bhanu, you are telling Frankel defect. I will come to that. So, that's where we have 2 positions where ions have moved. But at the same time, two positions they have not given where they have moved or they have been removed. Two positions, other two positions, still it is not clear because they have not shown whether those ions have moved to some other place. They have not given in the picture. So that means it has shown interstitial, that is dislocation. But at the same time, two ions have been knocked out. Right? So in that case, it looks like Schottky defect when we talk about knocking out. But at the same time, there is a moment. So therefore, we can go with option D. Option D, Frankel and Schottky defect. That is not happen, but according to this diagram, yes. Right? Whether I am clear why option D I am telling? Because here we can see two ions have moved to some other place, that is dislocation. Right? So that will happen in the Frankel defect. But two ions or two empty spaces, they have not shown whether those ions have moved to some other place. So in that case, I can tell that those ions have been knocked out from that particular position. They have been knocked out. So I can tell that it is both. The picture is showing both. Since option is there as Frankel and Schottky defect, then we can go with option D as the answer. All of you have understood? Any doubt? So always, whenever you find this type of images, first calculate what is the empty space, number of empty space, then find out where two similar ions are neighbors to each other. So whether if they are equal, then it should be a Frankel defect. If they are not equal, then it can be Schottky defect, means empty spaces, only empty spaces, there is no movement of ions. Then it should be Schottky defect. Right? If they are not equal, but there is a dislocation, then it should be both Frankel and Schottky defect. Okay? So all of you have understood? Next question. Which of the statement is incorrect? It is related to, I think, IIT question. So which of the statement is incorrect? As I told, I have not only included CET, NEET and all. Some of the questions were NEET and CET. Along with that, earlier question which was related to AIEE, another competitive exam. Okay, na? So this is which of the statement which is incorrect. Okay, this is related to IIT question. Option A. Coordination number. Coordination number I will write it as CM. Coordination number in cesium chloride crystal is 8:8, or you can simply write it as 8. B. A BCC crystal has coordination number 12. Option C. Particle in a unit cell are shared with other cells. D. The length of unit cell, that means they are talking about edge length, unit cell Na plus Cl minus is 552 picometer, where radius of Na plus is 95 picometer and radius of Cl minus is 181 picometer. So you have to pick the appropriate answer, which is incorrect. Okay, it should be incorrect. Anyone? Okay, Banu is telling B. Okay. Yes, actually it's easy question only. Yes, it is wrong. All of us we know body centered coordination number is 8. In BCC crystal structure, coordination number is 8. Go back to that particular table which I had given. It should be 8. But here they have given 12. But anyway, we will go with other option also. Cesium chloride, yes, it will have the BCC type of structure. Please remember. Cesium chloride will also form because group 1 element only, like NaCl. But NaCl is going to form FCC, but cesium chloride is going to form BCC type of structure. Okay. So where coordination number is 8 is to 8. 8 is to 8 in the sense cesium plus it will have the coordination number 8. That means it is surrounded by 8 chloride. Same way, chloride it is surrounded by 8 cesium ion. That's why they have given 8 is to 8. In turn, coordination number is 8. Now, in a unit cell are shared with other cells. Particle in a unit cell, that is quite common. FCC, face centered, it will be half, each shared by 2 unit cells. Body center is the one, only that particular atom is the one which belongs to that unit cell only. But all the other atoms, it will be shared. So C is also correct. Next D, we have seen, you have to calculate. So where 2 into RNA plus RCl minus. So then you will get the answer 552 picometer. Right? So that's where we have the answer, which is also correct. So therefore option B is the one which is incorrect. Right? Because in BCC, what is the coordination number? It should be 8, not 12. As for cesium chloride. Fine? So all of you have understood, right? So we will move to the next question. We will move to the next question. Okay, fine. This is also related to IIT only. So question number 16. In a solid AB, having NaCl structure, AB having NaCl structure, the atoms B occupy the corners of the cube. Occupy the corners of the cube unit cell. Corner of the cube unit cell. If all the face centered atoms, if all the face centered atoms, if all the face centered atoms along one axis, if all the face centered atoms along one axis, one minute, if all the face centered atoms along one of the axis, along one of the axis, along one of the axis are removed, then the resultant stoichiometry of the solid is option A, AB2, option B, AB, option C, A4, B3, then option D, A3, B4. So what is the question? In a solid of AB having NaCl structure, the atoms B occupies the corner of the cubic unit cell. They have not told about A. It's understood. Okay, na? So if all the face centered atoms along one of the axis are removed, the resultant stoichiometry of the solid is? That is the question. B, they have given. What about A? It is understood. Because they have mentioned it is a NaCl structure which is going to form face-centered type of unit cell in a crystal. Okay? So, can any one of you solve? Okay. Now, in this case, they have told about face centered, right? So, we will go with the face centered only. Okay. Now, all of us we know that in face centered unit cells, along with the corner atoms, I am just writing it as like this. Otherwise, they should be drawn with large size, and along with that, each face there will be presence of the atom, right? Now, according to that, what they are telling, B is at the corner. B atoms are at corner. That means it should be equal to 1. It should be equal to 1. Corner atoms. It should be equal to 1. Now it's understood that A is going to occupy the face of the unit cell. They have not mentioned, but I told it's understood because they are talking about face center. So that means A is going to occupy the face center. Now one statement they have given that along the one of the axis atoms will be removed in the face center. That means this can be that axis, this can be that axis, or this can be that axis, right? So that means I will take this one. This atom and this atom is removed. This is one axis. One of the axis is removed. We will consider, since A atoms are at face center, so in that case, total how many it should be? 3. Total how many it should be? 3, because 6 into 1 by 2 is equal to 3. But here, how many atoms are there? It is 4. So therefore, in this case it should be 4. So 4 into 1 by 2 is equal to 2. It's not 3, it is equal to 2. That means the difference between B and A is, if B is 1, A will be 2. Right? So apply that where it is applicable. A should be 1 more than that of the B. That's all. A should be 1 more than that of the B. No other option it is there. Only this option we can see. A 4, B 3. B is a 3 in number. A is 4 in number. So what I meant to tell of your understanding? Okay, they are asking about stoichiometry. They are not talking about exact formula. They are talking about stoichiometry. That means in that case I can say if B is 1, it is 2. That means 1 is more. A is 1 is more. In that case, if A is equal to 4, B should be 3, 1 less. Or if B is 3, A should be equal to 4. So based on that, I can go for this option because A, B 2, where B is more, that is not reality. A, B, they are not equal, that is not the reality. A 3, B 4, here also B is more, that is not the reality. In reality, A should be more in number. Therefore, option C we can take as correct answer.
So doesn't this become the base ratio between A and B atoms?
That's what I am telling. We are not talking about molecular formula. They are just asking what is the stoichiometry. Okay? So therefore we have gone with the option C. Fine? All of you have understood? All of you have understood? Any doubts? Okay. So in that case, option C should be the answer. Okay. So we will move to the next one. Even next one is also related to IIT question only. And that is also similar type of one only, where they are asking formula. They have given the information and they are asking formula. Okay? Fine. Now, question number 70. Oh, this is easy. That is not the one. Next one is that one. The coordination number. This is also IIT question only. Coordination number of a metal crystallizing in HCP, hexagonal close packing structure is. Simple question. So option A 4, option B 12, option C 6 and option D 8. It's simple question. Next one is another one. This is also IIT question only, a simple question. The coordination number of a metal crystallizing in SCP structure is. Yash Raj has written C. All of you will agree? Yash Raj is telling option C. Any other answer? Any other answer? Where is Banu today? Oh, okay. Fine. Okay. Banu has given option B. Now I am simply searching Banu Kumar because he was giving answer very quickly. Okay, na? Fine. So yes, Yashraj, 6 is not the answer. It should be option B. Banu and some other person has written. Rahul, yes, it should be option B. Don't get confused. So coordination number, I am talking about SCP. Coordination number is 12. Number of atoms in a hexagonal cube, because SCP is going to form hexagonal type of structure. Okay, so not cube. Hexagonal unit cells. Okay, so there it is number of atoms will be 6. In a unit cell number of atom will be 6. Okay, coordination number is not 6. It is a 12. Don't get confused. Fine. And I can tell that HCP is the only structure where unit cell will be having highest number of atoms compared to all the other structure. So where it is 6. But coordination number is same for SCP, CCP and all. It is 12 only. Fine. So don't get confused. So that's why we have the answer as B. Okay, next one. It is also IIT question only. Question number 80. A substance AX and BY crystallizes. AX BY crystallizes in a FCC, face centered cubic lattice, FCC lattice, in which atoms A, in which atoms A occupy each corner of the cube, each corner of the cube, and atoms B occupy center of each face of the cube. Each face of the cube. Oh, that's the straight away question. Identify the correct composition. Identify the correct composition of the substance. Correct composition of the substance AXBY. Okay. Now, option A, AB3. Option B, A4, B3. Option C, A3B. And option D, composition cannot be specified. Composition cannot be specified. Okay. What should be the answer? Any other answer? Mayank already has given the answer. Okay, already they have given. Banu and who is the another person? Yes, yes. It should be option A. It's a straight away question, right? So what they are telling? A occupies the corner, right? So that means it should be 1. And B occupies the face center. That means it should be 6/2. That is equal to 3. Right? So that means I have got the answer as option A, where A is 1 and B is 3. It is a straight away question. Okay? So next one. This is also easy. So I can see maximum question is on coordination number and finding the formula, right? Coordination number and finding the formula. Next one, question number 19. Sodium and copper crystallizes. Sodium and copper crystallizes in BCC. Okay, it should be actually reverse, FCC. Okay. Crystallizes in BCC and FCC respectively. Okay, sodium it is. I'm thinking sodium chloride. Respectively. Then the number of atoms of sodium and copper in that unit cell respectively is, okay. So option A 4 and 2, option B 9 and 14, option C 14 and 9, and D 2 and 4. Which should be the answer? Any other answer? Mayank has given the answer. Anyone else? Okay. So it's easy. Option D should be the answer, as Mayank has also given option D as the answer. Since sodium is forming BCC, it should be having two. Unit cell will be having body center, right? It will be having two atoms. Copper, since it is forming FCC, unit cell will be having four atoms, because in body center, corner atom and a atom present in the center of the cube. So total it will be two. In face center, along with the corner atoms which are present in the center of the face. So therefore it will be 4. So that's where we have the structure. Now along this, in this question they have given information also, where they are telling that sodium is going to form which type of structure? BCC. And copper is going to form which type of structure? FCC. Okay. So next one. Question number 20. Copper crystallizes. See, once again they are telling. Copper crystallizes in FCC with unit cell length of 361 picometer. What is the radius? What is the radius of copper atom? What is the radius of copper atom? What is the radius of copper atom? Option A, 109 picometer. Option B, 127 picometer. Option C, 157 picometer. Option D, 181 picometer. They are telling it is FCC structure. Yes, Raj has written option D. Okay. Yes, Raj has written option D. Okay. Fine. So anyone? Banu has written option B. Yes, actually option B is the correct answer. 127 picometer should be the correct answer. So you can make a chart where you can write SCP or CCP is equal to R. We have solved this one, R A divided by 2 into square root of 2, and in case of the BCC it will be R is equal to square root of 3 by 4 into A, right? And in case of the simple cube packing, it is R is equal to A by 2, right? So this one you can remember, you can make a chart, or while solving the packing efficiency we have done all these things. So what they have given is, they have given the length of the A, they have given the A value, and they are telling this one as FCC. FCC means first one. We should go for first one, right? So where I can tell that A is equal to 4r, diagonal axis, if you remember. A is equal to 4r. That is because when we were solving when we were deriving the equation, we had written like
A is
this,
equal to
right?
A root 2 is equal to 4.
Okay, 1 minute. Yeah. So here we have the 4r, right? So A is equal to, means here it is equal to 4r. So that means based on that I can tell that square root of 2a, right? So square root of 2a is equal to 4r. Square root of 2a is equal to 4r, right? That 4r we have modified, that's where we have got this particular value, 2 into square root of 2, by writing 4 in the form of square root of 2. So that's what we have got. Can you solve now? Solve it fast. So that means square root of 2 means 1.4. 1.4 into what is that A value? 361 is equal to 4 into R. R we have to find out, right? So find out R is equal to 1.4 into 361 divided by 4. So yeah, we are going to get 127 picometer. We are going to get 127 picometer. Don't get confused. So this also you have to remember, or you have to solve. You will be wasting time. Therefore I am telling you can practice that to avoid the time waste. And here square root of 2 is equal to 4r. So there 4 is not there. That is because this 4 we had written it as 2 into square root of 2 into square root of 2, if you remember. So that's where we have got 2 into square root of 2 in the denominator while deriving the equation. So this is where we have the information. A value they have given, then R value we have to find out. All of you have understood? So that's where the answer is 127 picometer. It will be 127 picometer. So next one, it is I think similar question problem we had solved earlier. In the next question it is there. Okay. The edge length of question number 21. Edge length of FCC cell of an ionic substance. So they have given a hint of ionic substance is 508 picometer. If the radius of cation is 110 picometer, radius of what is the radius of anion? What is the radius of anion? Option A 144 picometer, option B 288 picometer, option C 398 picometer, and option D 618 picometer. Which one?
Option.
Okay. So Mayank has already given the answer, which is correct. Anyone? Yes, very good. Banu Kumar also has given the correct answer, that is option A 144 picometer. Why 144 picometer? Because they have given FCC with ionic compound. FCC they have told, right? So that means where edge length, similar problem we have taken it as NaCl as the example earlier. edge length is equal to 2 into R positive and R negative, right? So based on that, they have given the edge length, right? That is 508 picometer. Then they have given the radius of the cation, that is 110 picometer, but you have to find out the radius of the anion. Fine. So if you solve it further, you are going to get 144 picometer as the answer, no doubt. You are going to get 144 picometer as the answer. Why we have to multiply it by 2? Anyone?
Just for it.
Because in the center of the edge also ion will be there. So therefore it should be multiplied by 2. Okay? So similar thing we have solved by using NaCl as the example in earlier case. So it is general one. They have not mentioned NaCl, but they have mentioned it as ionic substance. So by using that information we have calculated. Okay? So next one. Okay, this one will not solve. Okay. Formula only that I want. Okay. We'll go with this one. When the radius ratio, that is question number 23, right? When the radius ratio, I want you people to know this one. When the radius ratio is 0.4, the coordination number is, when the radius ratio is 0.4, the coordination number is, okay, option A 12, option 2 8, option 3 4, and A, B, C, and option D as 3. Option D as 3. What you can do is you can make a chart, okay? So where we can write it as radius ratio. Radius ratio is nothing but R plus divided by R minus. Naturally, whether we should get decimals, R plus divided by R minus means whether we should get the decimals, right? Yes, of course we should get the decimals because in the denominator large value will be there, right? So here coordination number, so here we can write the structure. Okay, you can go with even example also. That is not required actually. Example also. Then first one, if it is greater than 0.732, if radius ratio is greater than 0.732, coordination number will be 8. Coordination number will be 8. So it will form cubic structure. Okay? And cesium chloride, okay, earlier we have discussed, right? Cesium chloride is the example. If I take here 0.7323 to 0.4,